All right, first one. These symbols don't show up right on here, but which of the following could be used to prove that J and K are parallel, and so are M and N? So remember, on proving parallel lines, it's all about saying the converse of one of our theorems. So we had 5 of those. So converse of, and then we had corresponding angles, alternate interior, alternate exterior, same side interior, and same side exterior. So one of those 5 is good enough to prove that 2 angles or 2 lines are parallel. So it's on these probably a good strategy just to go through the options, since there's numbers everywhere on our lines. We don't know exactly what's given. So let's just kind of do a process of elimination. So if angle 1 and 3 are congruent and 5 and 6 are congruent, does that prove both sets of lines are parallel? Well, if 1 and 3 are congruent, which lines are for sure parallel? That would be J and K by the converse of corresponding angles. But 5 and 6 are on different lines. So that one, those won't work. Different transversals. Okay, and then if we prove 3 and 4 are congruent, those are vertical angles. Those are always congruent. So those don't even matter. Okay, if we prove 2 and 6 are congruent, that does prove 2 lines are congruent. Which ones are they? L and M, yep, by converse of the corresponding angles theorem. And then if 4 and 7 are supplementary, that is true. They should be, but that still just proves L and M are congruent or parallel, not J and K. All right, so hopefully this last one is good. If 5 and 7 are congruent, angles 5 and 7, it proves these 2 lines are parallel by what? Yeah, converse of alternate interior angles. And then 2 and 3 are supplementary. That does prove J and K are parallel by what? Which one of those? Well, what kind of angles are 2 and 3 on J and K? Same side interior, yeah, and so they're supposed to add up to 180. All right, number 2. What are the solutions to the equation? So we're just getting x by itself. First thing you want to do is multiply by 3 to get rid of the 1/3. You could also distribute it, but this gets rid of the fraction instead of making it worse. If you distribute 1/3, you'll have 2 fractions instead of just 1. And then this gets rid of it completely. Okay, and then this is quadratic. We see that because it has an x squared, so we want to set it equal to 0. And now we'll factor this. And we reviewed this yesterday, so hopefully it goes well. A times c is what in this one? Negative, yep. Negative 36. B? Yeah, negative 5. Okay. A is 1. So if there's nothing out front of x squared, A just is 1. All right, so we're looking for numbers that multiply to negative 36 and add up to negative 5. Anything coming up? Multiply to make negative 36, add to negative 5. Negative 9 and 4. Okay. And then we reduce, both of these are reduced, so our 2 factors will be x minus 9 and x plus 4. That's our 2 factors. And when we solve for each of those, what do we get? Remember we set each of these equal to 0. So 9 and negative 4. Raise your hand if you got that, if you got A, like with work, not just by guessing. Okay. Is it because of the fraction? Okay. Do your best to get rid of fractions by multiplying. That would be the best strategy. All right, number 3. So this one is kind of wordy, but I think if you make sure you just kind of follow what it says, the actual idea is easy. So AB and BC are the same. So AB plus BC is BC plus BC. So basically what we did was take this and stick it in there for AB. What's that called? That's just substitution, yeah. In our proofs, we've done that a whole bunch of times, right? If AB plus BC is equal, or AB and BC are the same length, then if we add AB plus BC, we can substitute either one where we want to. Okay, how'd that one go? Overall, the whole thing, I mean? Did okay on it? Okay. Let's check your homework. Any of them that you would like me to do before we start? Or before we just check? What was it? 15. Okay. All right. So a convex heptagon. That was one of our named shapes. How many sides does a heptagon have? That's 7. Has interior angles that measure these given ones. What is the measure of the 7th interior angle? I'll try to draw one. 1, 2, 3, 4, 5, 6, 7. Okay, it's not pretty, but that's okay. And if you don't have to draw the picture, but maybe it will help. I'll call it X, the unknown interior angle. So it's roughly a 7-sided heptagon, and I just filled in the angles that were given. So remember on these, we need the total first. These are interior. So we need to know how much they add up to. And that's just 180 times 7 minus 2, or 180 times 5, which is 900. Okay, so we know that all of these need to add up to 900. And then we'll just make this big long equation. And set it equal to 900. Okay. So we just have 1x. Basically, we just subtract all those from 900. And definitely don't want to do that in my head. One, 2, 3, 4, 5, 6. Okay, so x should be 155. Does that help? Okay, any others to do? All right, let's go ahead and check the rest, just answers-wise. Okay, number 3, x is 52 degrees. Remember, all exterior angles add up to 360. So in this case, we just had to do linear pairs with the 90 to get those exterior angles where the right angles were, and then just add them up to 360 and solve for x. X was 52. Okay, number 4, This is a pentagon. So pentagons have 540 degrees in their interior angles. And then we just add those, kind of like the one we just did. Actually very similar to that. And you should have got 141. Number 5, transfer or use linear pairs to get 70 on the other side of the 110 and 35 on the other side of the 145. Then add all the exteriors up to 360. And you get X is 95 on that one. Number 6 is a regular hexagon. And so we can just divide 360 by 6. So you get 60 degrees. On the back. Number 11. So I marked that B and D are congruent. Of course, A is 90 and then filled in C is 50. And this is a quadrilateral, so it adds up to 360. So we just added those all up and solved to get 110 degrees for angle B. Number 12, these are all exterior angles already. They add up to 360, so it's just kind of a long equation. Lots of X's and other terms. But once you do that, you get 28.75 for X. Number 14, another pentagon, so they add up to 540 on the interior. Another long equation, just boil all your terms down, all your like terms, and then you'll get X equals 19 when you solve. And finally, number 15, we already did. X was 155 degrees. All right, based on your work on the whole sheet, so that's 2 days, 2 nights of practice. Give me a fist of 5 on angle sums, both interior and exterior for polygons. Fist of 5. Okay. All right, well, onward then. We'll probably have a quiz on this stuff and the stuff we're about to do towards the end of next week. Maybe Wednesday, but probably Friday next week. Just like a partial unit quiz on a couple sections. So if you're struggling at all with the angles, let me know. But your numbers kind of suggested they were pretty good. The sheet I just handed you has a bunch of quadrilaterals on it. And basically, let me actually show you maybe what this looks like. I guess, did you already have it in your note packet? You didn't, right? Okay. So this is going to be considered a note, and I probably will end up letting you use it on quizzes and tests. So do a good job taking the notes on here. Basically, what this is going to have when we're done, every one of these quadrilaterals is going to have a number of properties. By the time we get down to a square, we're not going to write them all, but it has 10 properties, a square does. 10 different things that are true about it that we'll need to use and remember in order to solve. So this is going to be a pretty full and busy sheet when we're done. So like I said, do a good job writing stuff down and make it clear. If you lose it, definitely ask me to get you another one. And I'll post it each day when we fill more stuff out. You could get on and catch up if you happen to lose your sheet. The big idea here is now we're shifting gears to quadrilaterals only. So this whole, basically the rest of our unit, with the exception of a few problems, the rest of the unit is about quadrilaterals. So 4-sided shapes. And these are them, all the different ones. So maybe make sure that's clear. The first 2 that we'll study, well, actually, before I say that, you can kind of see this is a flow chart sort of idea. So if I look at the top arrows, it's broken down into 3 different main types. So a parallelogram, like top category, kite main category, and a trapezoid top category. And then each of those, with the exception of kite, each of those has subcategories or more specialized versions of themselves. And each of those special versions has additional properties. So we're going to start with kites and trapezoids first, and specifically kites. I don't know how far we'll get today, but kites first. Did you know that a kite is a name of a geometric figure? I didn't. Yeah, I certainly didn't know that growing up. Like, I just thought it was a kite was something that we fly with the string, right? But it actually is the name of a geometric shape. And it certainly has all these specific properties. So on yours, some of the stuff is marked, but it's not very clear. So I think colors can help things stand out. And we'll make a list as well, but definitely use some color. What do you notice about a kite? Like, what would you describe it as? Like, what was it? Okay, kind of looks diamondish. Sure, good job. What else? Yeah, she said 4 triangles. So 2 little ones and 2 bigger ones. But then we also have 2 halves that are triangles as well. So we just finished a unit on triangle congruence. And guess what? Kites have a ton of congruent triangles inside of them. And so that should help you to remember some of the properties because, remember CPCTC? What did it mean? Don't write this, I'm just putting it up here to talk about it. What was it? Yeah, if we have congruent triangles, then the parts that correspond are congruent. And that helps a ton with kites because, for example, if I tell you that these 2 triangles are congruent, which they are, well, now that we know that, we know that these 2 outer diagonals are congruent. We know these 2 parts in the middle are congruent. We know angles are congruent. Like, everything that corresponds is congruent, and that really helps us with properties. Same thing if we do the whole thing like that. Now we know parts of those whole triangles are congruent as well. So I would say, like, now start writing with kites. I'm going to say big idea is congruent. Let's use the symbol congruent triangles. Okay. Each of these figures have lines that go through the middle of them if we want to draw those in. Those lines are called diagonals. So, like on this trapezoid, I'm just going to borrow it for a second. If I draw these 2 lines in, those are called diagonals. And they connect opposite vertices in our figure. No, that's not what I want. So up here at the top, I want you to just define that real quick. So a line through the quadrilateral that connects opposite vertices. Okay. Well, with that, you can see 2 diagonals in this kite, right? It's where the string would connect. What do you think is true about them? What is shown to be true about them? They are what? What does that symbol mean? That right there. Okay, so diagonals are perpendicular. And it's already marked, but if you want, you can make sure that's showing better. Now, if one of those angles is marked as 90, what's true about all three of them, or all four of them, excuse me? They're all 90, right? Every one of them is 90. So perhaps we're working, don't mark this, but let me just give you an example problem. Maybe I tell you that this length is 10 and this length is 5, and I want to know that length right there. Well, what would you use to solve for x? Knowing that this is a 90-degree angle right there. What would you use? Yeah, so Pythagorean theorem, okay? Because these are perpendicular, that's going to allow us, or maybe force us, to use the Pythagorean theorem sometimes. Let's put that little subnote here. Just a reminder that because it's 90, we can use a squared plus b squared equals c squared. Okay, number 2, second property. The long diagonal bisects the short one. What does bisect mean? Yeah. Okay, so make sure that is showing. That means these two little segments, we don't have a center letter, but like A to the center, B to the center, those are congruent. So it's split in half. Now, do you think that's true that the short diagonal bisects the long diagonal as well? Is it a vice versa thing? Here's how you can check. If you make like a real ridiculous looking kite, like this, does it look like the short diagonal bisects the longer one? No. Okay. So it's not true both ways. Only the long bisects the short. And so maybe say not vice versa. Okay, next property. This is not shown in there. The long diagonal bisects the angles on it, meaning that angle is bisected, and this angle is also bisected. So make sure that gets marked on your figure. Do you think this short diagonal bisects the, like in this picture, A and B, angles A and B? Nope. So just to clarify, not the short diagonal, it does not do this. Okay, property 4. The two angles on the short diagonal are congruent. Now that is marked in the figure, but we need to add a few more lines so that our notation is correct. So that angle and that angle are congruent. A lot of this can be determined if you just remember CP, CTC. In fact, all of it can. Other than the fact that the diagonals are perpendicular. That's why I gave you that one first. And you know what, just to remind you, perpendicular up here, I'm gonna write 90 degrees in there. And then there's two other markings on here, and that's kind of the definition of a kite. So I'm gonna put that right here as a definition. And that will take care of the other markings that we haven't talked about. So this is a quadrilateral. At some point, we'll just start abbreviating quadrilateral as quad, because it gets old writing that. So a quadrilateral with two pairs of congruent. Here's the keyword that separates it. I can spell it right. Consecutive sides. Consecutive means one after another. So if you look, if we start at A, that side and that side are congruent. So they are next to each other. They're consecutive as we go around. And then this side and this side are congruent. Those are the other two consecutive sides. So we have two pairs of consecutive sides that are congruent. Okay, and you can see those are marked in there in the figure. So make sure those really stand out. So those two sides and these two sides are congruent. A lot going on in a kite. One of the biggest things about it is those 90-degree angles in the middle that form 90 or right triangles that we can use to solve for things. Okay? Now, I told you could probably, I'll let you use this sheet on your tests and quizzes, but there's going to be a lot of stuff on here. And so if you are just relying on having your paper, that's going to probably cause trouble because you won't know what's on it. So start memorizing these. In fact, I might even give you a little check quiz that's here, fill out all the properties without the sheet, just to see where you are with it. Okay, so a definition and 4 properties, that's 5 things, but mostly you can get all of them with the exception of the diagonals being congruent, or excuse me, perpendicular. You can get all of these properties remembering that CPCTC is existing here. Any questions on them, on the properties? All right, let's go see how these are going to be used in problems. Some of this we already wrote. Okay, we'll start off with easy ones. You don't need to write these, we can just answer them, but don't shout them out. So measure of angle AXB. AXB is this angle right there. So what's the measure of angle AXB? Raise your hand. Actually, don't. Just, I'll give you 10 seconds to think, and then I'll say what's the measure. Okay, go. Yep, that's 90. In fact, all of those are, so we could draw all these 90s in here, right? And make it look like a little box. All right, next. If AX is 3.8, what is AC? Don't shout it out. 10 seconds. Okay, what's AC? Yep, 7.6. So AC equals 2 times, I'm going to do a dot, 2 times AX. All right, next one. If BD equals 10, and that's hard to show because if I write it, it looks like it's just part of the length. So I might just do it this way. If BD equals 10, does BX equal 5? Okay, what do you think? Why not? BD is not bisected, right? That's the long diagonal. And when we wrote this in our notes, we described it as long and short. And most of the time, it's pretty obvious which one is which, okay? But DB is the long diagonal, and it is not bisected. All right, good. All right, measure of angle 1. You don't really need the right side. We're told this is a kite, so I'm going to zoom it to that level so you can see it. So measure of angle 1, let's do this one a little quicker. What is it? 90 degrees, okay. Measure of angle 2. This one you might want a calculator for, or probably you can do it in your head. Okay, what's measure of angle 2? 55, good. We're just looking at this triangle, and we know that we have a 90 in there, so it's 180 minus 90 minus 35. Okay, before we do 3, what is the measure of angle Q? Measure of angle Q. What was it? 110. Yeah, that one is bisected, right? So we know that 2 is congruent to the other side, and so we just double the 55. All right, number 3, what is measure of it? Huh? Oh, 35. Okay. 35. Good. So keep in mind, because there are triangles in here, the 180 degrees in a triangle still applies for sure. All right, let's do some side length stuff. And this one, I think I'll probably do an example of. So grab your notes. Let's go put this one in there. I'll give you a second to draw that. First thing I would encourage you to make note of is this is lengths, not angles. And I would say label. So label your picture with what you know. The reason that we're doing lengths or angles, I mean, I think it's obvious, but sometimes students get mixed up and use an angle property on lengths, like setting it equal to 180 or something. And that just doesn't work. Okay, number 2, label the figure. So OL is 2x minus 2. OM is 35. MN is 37. we're going to identify needed properties. For either lengths or angles. Well, this is a lengths problem. What were some properties of lengths in a kite? That's kind of the process that we'll use. So you go to your kites. If you have them memorized, that would be awesome. That's the best thing. But if not, and it's too early probably for that, you grab your sheet and you say, okay, I'm dealing with lengths. So which properties do I need? Well, we know, I'm just going to temporarily put some dots on here. We know this kind of length, we know this kind of length, and this kind of length. So what could we do that relates any of those together? What properties do we have? Well, I see that we're dealing with diagonals, so what's true about them? Meaning I have dots on two diagonals. Okay, so we know the short one is split in half. That's going to be important. We also know that they are perpendicular. These two diagonals are. The 90-degree thing. Okay? So with that, let's go see if we can use that to help us out here. And yeah, okay, so I see that this short diagonal is bisected, so those two pieces are congruent, which means what can I do with the 2x minus 2? Yeah. So we'll grab that and just copy over here. Copy 2x minus 2. Okay, so now at least we have all the three given pieces are all together. And so I also said, let's make note that these are perpendicular. So I am looking at this triangle. Why? Like, what good does looking at that triangle do? Well, we're ready to set up some kind of equation. Which one? So the three sides are in a what kind of triangle?
Right triangle.
Are in a right triangle. So what's the relationship that we're going to use? Okay, a squared plus b squared equals c squared. That's the Pythagorean theorem. We know that in a right triangle, those are the side lengths. Which one always has to be in the right spot? The longest one, which is C. Okay. Guys, we're doing a lot just to get this set up. And this particular problem has a lot of work to solve. So hopefully you're following along and you're making sure to get this. Maybe answer my questions so you can make sure you are. A is 2x minus 2. That whole thing squared. B is 35 squared. Those are added. C, 37 squared. All right, we're to the point where we're done with geometry for the moment. And really, on this one, we're done with geometry for the rest of the problem. That's a lot, though, just to get an equation set up, isn't it? Like, we had to know it was a kite, or be told. We had to know which properties of a kite to use. We had to know how to set them up. And then I want you to take that times all the figures on your sheet. That's what your final test looks like. It's a lot to know, so you need to start studying today. Well, 37 squared, 35 squared, those are just numbers. Let's do them. So 37 squared, 35 squared. So 1369, 1225. Okay, but what is 2x minus 2 squared? Yeah, so I thought someone would probably say that, and we have to be careful because it's not actually that. What does squared mean? Yeah, this is times itself, right? So it's this, 2x minus 2 times 2x minus 2. And so the 4x squared plus 4 is true, but we have a middle term actually in the middle of that. So we get 4x squared and then minus 8x plus 4. Okay. If you need me to do that, please let me know right now. If you need me to expand that out. Yes? Okay. Thank you for saying something. I will scoot this down. Oh, it didn't work. One more try. Scoot that down. Okay. Okay, here's how that's going to work. We're going to distribute the 2x, and we'll get 4x squared minus 4x. And then we'll distribute the negative 2 as well, and we'll get negative 4x and plus 4. Okay, and then we combine the middle two terms to get negative 8x. All right. So now we're sitting here looking at a quadratic with big numbers. How do we solve quadratics? This is one reason we review these things. How do we solve a quadratic? Yeah, we will, but we need to set this equal to 0 first, okay? Yep, so let's subtract 1369. And now, like he said, we'll combine all these three like terms right here. So 4 plus 1225 and then minus 1369. And we'll get negative 140. All right, that looks good. Looks more familiar, I should say. Okay, this is where we definitely want to pull out a GCF before we do any factoring. What's a good GCF on this one? Yeah. So divide each by 4 and stick that out front. Actually, since we're solving, I'm just going to divide everything by 4. That'll save us a step. Okay, 140 divided by 4, what is that? 35, I think. Okay, now we factor, so star. And we reviewed this in the warm-up yesterday and today. What is A times C? Negative 35. B? Negative 2A. Okay, are there numbers that multiply to make negative 35 that add up to negative 2? Numbers that multiply to 35. 7 and 5, good. And then in this case, we need negative 7 and positive 5 to make the negative 2. Okay, anything we can reduce here? Nope, so these are both already reduced. And so we're going to take those and say x minus 7. X minus 7 times x plus 5 equals 0. Okay, remember this is the step. One of those, or maybe both, is 0 for this to whole overall be 0. So we split this and set each one equal to 0. And we get these two results. Why am I not circling -5? Will a negative work up here if I plug -5 in for x? No, because it makes the side length negative. That doesn't work. Okay? So in this one, it can't be negative. I'm not saying it never can, but this one, I'm just going to actually not say it that way. Let's just say it doesn't work. Okay, so our answer is x equals 7 after all that work. Quick review. We decided, is it lengths or angles? Then we said, let's go put information in the figure so we can see how things relate. Then we picked our properties off the list. And in this case, we needed the fact that those diagonals are perpendicular and that we can copy 1/2 of the short diagonal over. And then we set up an equation to solve. There's a little bit more work in the solving on this one, but that's a pretty typical solving process on these kind of problems, okay? Some of them will be shorter, and probably not very many, if any, will be longer than this. Questions on that? Okay. Try this one. It's shorter. I'll give you that hint before we get into it. Okay, first of all, is this lengths or angles? Okay, which property do we need? Actually, let's label first. So OB is 8 plus x. OD is 5. So which property do we need? It's a kite, like we know that. Later on, we'll need to also identify what shape it is, but right now this is all we know. So it's a kite. What property out of the 5 do we need? Yeah, the second one that said that the short diagonal is bisected, right? Meaning that these two BO and DO, they are congruent. So how do we set up our equation then?
8 plus x equals 5.
Yeah. Way shorter than the last one. X equals -3. Wait a minute, I thought we said we can't have a negative. Actually, that's not what I said. What did I say? Can't have negative lengths or angles. Does that happen in this one? No, we're safe. But just keep in mind, though, that you do need to check. All right. Any questions on these? You want to do any more? You feel ready to practice on your own? Would do more or practice? I think you said practice. This sheet has trapezoids and kites, so I'm handing you the side up that has the kites on it. Okay, so on that side, the side with the kites, do all of them, so it's 20 to 30. Actually, sorry, 18 to 30, because the 18 and 19 are word questions about kites. So 18 to 30. as you work, keep that reference sheet handy so you can start getting those memorized.